Hello, grade 7. This is your math video for page 86, which is one of those green mid-chapter practice tests, and it's numbers 1 to 20, all of them. Let's look at number 1. Name 3 numbers that are between 1/2 and 3/4. 3 numbers that are between 1/2 and 3/4. Well, let's start by drawing a number line and think about what 1/2 and 3/4 are like. 1/2 is halfway between 0 and 1. We know that this would be 1/4, hopefully, and we know that this would be 3/4. They're asking for the names of 3 numbers that lie somewhere in between here. Now, we could do this a number of ways. We could write fractional answers, or we could write decimal answers. Okay? You're supposed to come up with 3 numbers that are somewhere in here. I'm going to do this same problem, but what if I'm looking for numbers that are somewhere in between here? Here's how I do it. Okay? There's a couple ways. If I write down 1/4 and I write down 1/2, and I make them into equivalent fractions that have the same denominator, but I'm going to look for a pretty big denominator. What if I change them into fractions that have 12 as their denominator? If I do that, 1/4 becomes 3/12, and 1/2 becomes 6/12. Doesn't it make sense then that the numbers of 4/12 and 5/12 have to be in between these 2 numbers? And if they're in between these 2 numbers, they have to be in between these 2 numbers as well? What if I made the denominators bigger? What if I changed these both into fractions that had 20 as their denominator? That would make this 10/20, and it would make this 5/20. And thinking about these numbers, doesn't that mean that 6/20, 7/20, 8/20, and 9/20 all have to be between these 2 numbers? And thus, all of these numbers would have to be between these 2? Yeah. Here's another way of looking at it. So this would be possible answers for numbers that are between here. What if I change these into decimal numbers? This is 0.25, and this is 0.5, right? Now notice I wrote it as 0.50. 1/4 is 0.25. 1/4 of a dollar is 25 cents. A half a dollar is 50 cents, right? What's in between these numbers? Well, a whole slew of numbers, right? 0.26, 0.27, 0.28, 0.29, 0.30, 0.31, 0.32, 0.33, and so on, and so on, and so on. So there's a couple approaches you could take on this problem, couldn't you? You could either take this fractional approach between 1/2 and 3/4 and find a bunch of numbers that are between it. All I did was change them so that the denominator was a much bigger number. These fractions are the same as 1/4 and 1/2, but I come up with those. Or I wrote it as decimal numbers and then found the ones that are in between. Either way. Look at number 2. Define reciprocals. And then give the reciprocal of 2/3. Well, do you see where it says lesson 2-4? If you go to lesson 2-4, they have a definition for reciprocals right there. Write down the definition of reciprocals for number 2. If you don't remember what a reciprocal is, let's say they asked you for the reciprocal of 7/9. The reciprocal of 7/9 is 9/7. Okay? Reciprocals are 2 numbers that when you multiply them together, you get the number 1. Reciprocal of 7/9 is 9/7. You just flip the numbers. Number 3, write an addition problem that has a sum of 2 2/3. Write an addition problem that has a sum of 2 2/3. In other words, they're saying, do this. But you're going to have to fill numbers in here, okay? You got to come up with the numbers. I'll try one that's slightly different. What if I had the numbers 3 3/4? And somebody said, give me an addition problem for that. Well, to me, it's pretty easy. Just write 3, write 3/4, and you're done. There's an addition problem that has an answer of 3 3/4. Okay. How about Number 4 rather. Number 4. They want us to write -2/9 as a decimal. I'm not going to do that one, but I will do this one, -7/9. How do I turn that into a decimal? Well, long division. 9 divided by 7. Maybe, though, you remember the trick for this, but I'm just going to do the work. What do you notice is happening? It's just repeating 7s over and over again. So this is -0.7 repeating. -0.7 repeating. -7/9 is -0.7 repeating. So I'll do the same thing with this one. Number 5, write -2.65 as a mixed number in simplest form. As a mixed number in simplest form. I'm not going to do that one, but I'll do one that's similar to it. They want you to do this one. I'm going to do this one. Well, one way to read this is to say -3.15. But a more accurate way is to say -3 and 15/100ths. And guess what? That is the fraction form for this. Now, can I simplify this? Sure. Divide by 5. And when I do that, I get this as my answer. So that's what they want you to do with this one. How about number 6? Write 0.5 repeating as a fraction in simplest form. I'm not going to do that one, but I'll do one similar. What if the problem was this one right here? Well, I talked about this. Remember, I told you that this equals 1/9, and that this equals 2/9, and that this equals 3/9. If that's the case, then this has to equal 4/9. Let's move on. Number 7, they want you to decide which one's bigger, 1/3 or 1/4. 1/3 or 1/4. I'm not going to do that one, but I'm going to do one similar to that. What if it said 2/3 and 3/4? Which one's bigger? Well, the first thing I'm going to do is I'm going to change them into fractions that have a common denominator. The common denominator is 12. This would be 8/12, and this would be 9/12. How did I do that? Well, 3 times 4 gets me to 12, so I take this times 4. 4 times 3 gets me to 12, so 3 times 3 gets me to 9. It's got to be, in this case, whoops, no, I didn't do that problem. I'm sorry. I did this problem. 2/3 is less than 3/4. How about something like number 8? Same type of work. You don't have a common denominator there. I will say be careful. In number 8, both of the numbers are negative numbers. So remember, when you have a number and it's negative, it's actually the one that seems smaller that's the bigger one of the two. So be careful about that. How about number 9? I've got a repeating decimal and I've got a fraction there. How do I tell which one is equal to, or which one is greater than, or which one is less than? Well, I'd recommend you change the fraction into a decimal number by long division and see what happens. When you get down to 11 through 16, be careful. Some of them are multiplying, some of them are dividing, some of them are adding, and some of them are subtracting. Remember, they have different rules for multiplying, dividing, adding, and subtracting. So be careful. Do you remember how to find the area of a rectangle? Number 17 says the formula is length times width. It's a multiplication problem. Multiply the length by the width to find the area. Number 18, a board is 25.5 feet long. It's cut into 2 equal pieces that are each 1 1/2 feet long. No, not 2 equal pieces, into equal pieces. How many pieces is the board cut? Okay, I said that wrong. They've got this board. It's 25.5 feet long, a pretty long board. And they're cutting off chunks of 1.5 feet over and over again. Chunks of 1.5, chunks of 1.5. They want to know how many chunks you're going to end up with. Well, what if this was an easier problem? What if instead of 25.5, it was a board that was, say, 16 feet long, and they're cutting off chunks that are 2 feet in length. And they want to know how many chunks you can make out of this. 16 feet long, each chunk is 2 feet. Well, that's the division problem, isn't it? 16 divided by 2, you'd end up with 8 pieces. Same thing here. This is a division problem, right? They're dividing up a board, a long board, into smaller sections. Oh, number 19. Number 19. They just want you to change that decimal number into a fraction. I'll give you an example of something that's similar to that. They have 0.392. I'm not going to do that one, but I will do one that looks like this, 0.8380. First, I change it into a fraction. It's going to be thousandths because I'm filling the tenths, the hundredths, and the thousandths spot. And then I simplify. I'm going to divide by 10, and then I'm going to divide by 2, and then I'm done. That's all they're asking you to do there for 19. 20. Bag of candy is 12 ounces. Each piece weighs 1/6 of an ounce. Write a division problem you could use to determine the number of pieces of candy. And then it says how many candies are in the bag. In other words, they want you to write the problem and then solve it. Okay? And it's a division problem. So obviously you're going to be dividing 12 by 1/6. Don't forget the rule about division. To divide, you multiply by the reciprocal of the second number. Okay, thank you.